In this video, let us see some of the important questions on functions in C programming. First question, name the different types of parameter passing, illustrate each of them with an example. This question has been asked in almost all the previous university examination in different format. It can be like this: discuss the difference between call by value and call by reference parameter passing techniques with the help of suitable examples, or discuss the different parameter passing techniques or with suitable example, explain different function parameter passing methods in C, explain call by value and call by reference in C, explain the various function parameter passing methods with examples. The answer is, in C programming, there are two types of parameter passing, call by value and call by reference. Call by value. In call by value, a copy of the actual parameter's value is passed to the function. Since formal parameter is copy of actual parameter, any changes made to the formal parameter inside the function do not affect the actual parameter. Let us see an example. We have got a function increment which takes an integer variable. Inside the body of the function, the variable is incremented by 1, num equal to num plus 1. In the main function, we have a variable value. It is set to 5 and the value is passed to the increment function. Value is the actual argument. Here we are passing the value of the actual argument to this formal argument. Value 5 is copied to the variable num, and then num is equal to num plus 1 means the num is incremented to 6. After executing the function, it will come back here, and the next statement, print of value after calling increment, percentage d, the value. Since no changes has happened to the variable value, we will get 5 itself. Here the original variable remains unchanged after the function call. This is an example for call by value method. In this approach, the second method is call by reference or pass by reference. In this approach, the memory address of the actual parameter is passed to the function. In call by reference, formal arguments are pointers to the actual arguments. Since we are passing the memory address, the formal argument will be pointers to the actual arguments. Hence, any modifications made to the formal parameter inside the function directly affect the original value of the actual parameter outside the function. We will see the same example. Here, we are passing the address of the actual argument. So that is why we put ampersand value to the function. Since we are passing the address, the actual argument will be a pointer. So in star num ptr, then star num ptr plus 1. So that means here we are pointing to the variable value. The content of the value will be incremented by 1. So here star ptr means it represents the content of the variable value. Num ptr contains the address of the variable value. So star num ptr means the value inside the variable value. So 5 plus 1, it is 5 plus 1, that is 6, will be stored in the variable value itself. So after executing the function, it comes back here and print of value after calling increment. Here the actual value changes. So here we will get value after calling increment, it is 6. Here the original value is modified inside the function. What are the advantages of modular programming? Modular programming is an approach in software development where a large program is divided into smaller manageable pieces called modules. Each module performs a specific task or function independently. The advantages of modular programming include: first one, code reusability. Modules can be used in different parts of the program or even in other projects. This saves time and effort by eliminating the need to rewrite the same code repeatedly. This prevents redundancy and enhances the efficiency of the development process. Easy maintenance. When a program is split into smaller modules, finding and fixing bugs or making improvements become easier. When changes are made to one module, they are less likely to affect other modules. This simplifies the process of debugging and maintaining the program. Enhanced collaboration. Developers can work on different modules together at the same time. This parallel development promotes teamwork and speed up the overall development process. Scalability. Modular programs are easier to scale and extend because new functionality can be added by creating new modules or changing existing one without affecting the entire program. Encapsulation. Modules encapsulate their internal workings and hide implementation details from other modules. They only show the important interfaces to other modules. This separation helps to minimize the chances of unintended problems. Testing and debugging. Modules can be independently tested. This makes it easier to identify and isolate bug. So these are some of the advantages of modular programming. Next question. Define formal parameters and actual parameters. Illustrate with an example. Differentiate formal and actual arguments in a function. Describe actual parameter and formal parameter of a function in C program with example. Formal parameters. The parameters that appear in the function header of the function definition are referred to as formal parameters or formal arguments. They act as a placeholder to receive the actual values provided to the function when it is called. Actual parameters. Actual arguments are the values that appear in the function call. They represent the real data passed to the function when it is called. These are the actual values that the function will work with during its execution. Actual parameters can be constants, variables, or expression. Let us see the example. Here we have got a function, calculate rectangle area. It has got two parameters, length and width. And inside the main function, we are calling that function, calculate rectangle area, with two parameters, length value and width value. Here, length value and width value is the actual parameter that we pass to the function. The parameters inside the function header, that is the length and the width, are the formal parameters. They act as a placeholder to receive the values of the actual parameters. Next question, with examples show how an array is passed as argument of a function and individual elements of array is passed as arguments of a function. When passing an entire array to a function, only the name of the array is passed as an argument and it is treated as a pointer to the first element of the array. Therefore, the formal parameter in the function should be a pointer. Here you can see that my array is an integer array with values 1, 2, 3, 4 and 5. We are passing this my array to my function. So here we are passing the entire array. Name of the array is given, my array, and its size 5 is given. Since array name is a pointer, the formal parameter should be a pointer, int star array. In C, we can pass individual elements of an array to a function in two ways, by passing the data values directly or passing by their addresses. When passing the individual element of an array by its value, the data type of the formal argument in the function should be the same as that of the individual array element being passed. Here example, my array is an integer array and the index value is set to 2. I'm going to pass this third element, my array of 2. That means my array of 2, the value at the third position, 30 is being passed to the function. Since 30 is an integer element, the formal argument should be an integer. So int element will receive the value my array of 3. So that means 30 will be passed to the function and it will be stored in the formal argument element. On the other hand, when passing the address of an individual element, the formal parameter should be a pointer. Here, for example, I'm passing the address of the third element and return my array of index. Since this is an address, the formal parameter should be a pointer in star element ptr. Next question, what is the purpose of the function declaration and function definition and function call? With example, illustrate that syntax. A function in programming is a self-contained block of statements that perform a specific task or a set of tasks. The part of the function are as follows. The first one is function definition. A function definition provides the actual implementation of the function. It contains the code that executes when the function is called. The syntax of function definition is return type, function name. Within the bracket, we specify the parameters. Within the curly braces, specify the function body. Example of a function definition, int add numbers is the name of the function. Int, it is a return type. And it accepts two parameters of type integer, in num1, in num2. Then inside the function body, it calculates the sum of num1 and num2 and then return the sum. Since the sum is an integer, we provide the return type as int. Function declaration. Function declaration, also known as the function prototype, informs the compiler about the function's name, the number and type of parameters passed to the function and return type of the function. The function declaration must appear before the function call in the code. It tells the compiler that the function will be defined later in the code. The syntax of function declaration is return type, function name, within the bracket parameters, and after that we put the semicolon. Example of function declaration. The function declaration for the function we have defined earlier is int add numbers in num1 comma in num2, then put the semicolon. Function call. A function call is a part of the code that invokes or executes a specific function. When the program reaches the function call, it transfers control to the function definition, execute the code inside the function, and returns the result, if any, to the point of the call. The syntax of a function call is function name, within the bracket we specify the actual arguments and then put the semicolon. For example, here we have got two variables a and b. In order to find the sum of these two values, we pass it to the function add numbers. Add numbers within the bracket a comma b and then put the semicolon. This is the function call. Next question, write a C program to find the sum and average of an array of integers using user-defined function. Function to calculate the sum of the elements of the array. I've given the name find sum and the sum will be an integer, so the return type is int and it accepts two parameters. First one is an array and the second one is a integer that accepts the size of the array. We are expecting an array. We just give a empty square bracket here. Int sum is equal to 0. For int I equal to 0, I less than size I plus plus, sum equal to sum plus ARR of I. Then return sum. Now function to calculate the average of the elements in the array. So this function takes the array and then the size of the array as the argument, then calls the function find sum with the array and the size. So this function will return the sum of the elements in the array and that sum is stored in the variable sum. Now sum by size gives the average value. So that value is returned. Since the average is float, we write the return type as a float. Now we write the main function. In size, enter the size of the array. The size of the array is stored in the variable size, scanf %t and resign size. When the array is declared, printf enter the elements of the array. The array elements are read inside the loop. For I equal to 0, I less than size I plus plus, scanf %t and resign ARR of I. This is for reading. Then we call the find sum function to find the sum of the array and it is stored in the variable sum. And we call the find average function to find the average and the average is stored in the variable sum. Next, we print the sum and then average and then return. Next question, what are library functions? Library functions are predefined functions that are built into the C programming language. They are part of the C standard library and are available for use in C programs without the need for explicit implementation. Library functions in C cover a wide range of operations such as input, output, mathematical computations, memory management, string manipulation, etc. To use a library function in a C program, the corresponding header file that contains the function's prototype should be included. This is done using the preprocessor directive #include. For example, to use the printf function, the stdio.h header file must be included. Next question, what is the use of function prototype? Give the function prototype of a function accepting one float value and an integer array and returns a float array. The function prototype serves as a declaration of the function before its actual implementation. The function prototype, also known as the function declaration, informs the compiler about the function name, the number and type of parameters passed to the function, and return type of the function. The function prototype must appear before the function call in the code. It tells the compiler that the function will be defined later in the code. The function prototype for a function that accepts one float value and an integer array as parameter and returns a float array. So here the return type is a float array, so it has to be declared as a pointer to float. Float star, then function name. It is given as my function. Then it accepts two parameters. First one is float, comma, then it is an integer array. So we can put either int star or you can put int empty bracket. Then we put the semicolon. So in this prototype, the function is made my function. It accepts two parameters, a float value and an integer array. The return type of the function is float star, indicating that the function will return a pointer to float array. Next question, how do you interpret the following function declaration? Int star p within the bracket char square bracket. The following function declaration can be interpreted as follows. P is the name of the function. It takes one parameter, a pointer to character array, and it returns a pointer to an integer. That is why it has been put as int star. Next question, what are function prototypes? Is function prototype mandatory for every user-defined function in C? Justify your answer. The function prototype serves as a declaration of function before its actual implementation. The function prototype, also known as function declaration, informs the compiler about the function's name, the number and type of parameters passed to the function, and return type of the function. In C, function prototypes are not mandatory for every user-defined function. They are required only when the function definition is after the function call in the code. When a function is defined before its call in the code, the compiler already knows about the function signature. In such cases, the compiler can perform proper type checking without the need for an explicit function prototype. Next question, list out the main component which comprises a function definition. A function definition in C consists of two main parts, the function header and the function body. The function header. The function header, also known as the function prototype, is a part of the function definition that appears before the function body. It includes the following components. Return type, the data type of the value that the function returns to the calling code. Function name, the name of the function which is used to identify and call the function in the code. Parameter list, the list of input parameters, if any, that the function receives from the calling code. It is specified within the parenthesis following the function name. Function body. The function body is a part of the function definition that contains the actual statements which define the action or operations performed by the function. These statements specify the task the function executes when it is called in the program. So this is the syntax, return type, function name, within the bracket parameter list. This is a function, and we write the statements, and whatever statements inside the curly braces forms the body of the function. Next question, consider the following function declaration. Void display int, int display int. Differentiate between the two declarations. The two function declarations are different in the terms of their return type. Let us differentiate between them. Void display int. This function declaration specifies a function named display that takes an integer parameter but does not return any value. That is why void is given as the return type. Int display int. This function declaration specifies a function named display that takes an integer parameter and returns an integer value. Next question, what is the purpose of return statement? Can multiple return statements be included in a function? Justify your answer. The return statement in the function serves two main purposes. Termination. The return statement is used to terminate the execution of the current function and return control to the calling function. The second purpose is returning a value. In addition to terminating the function, the return statement can also send a value back to the calling function. Syntax of return statement. If you write just return control from the function without a return value, return with expression, return control from the function that returns a value. Here, expression is the value or result that the function wants to return. Example, int add in num1 comma in num2. Here int sum is equal to num1 plus num2 return sum. So this return statement returns the value of the variable sum as the result. Yes, multiple return statements can be included in a function, but only one of them will be executed during the function call. When a function contains multiple return statements, each return statement should be placed within a conditional statement. This ensures that only one return statement will be executed depending on the specified condition. This is required due to the fact that a function can return only one value at a time. For example, int find max int a comma int b. If a equal to b, return a, else return b. Here we have included two different return statements, but only one will be executed at a time. If a is greater than b, then this return statement will execute. Otherwise, the second return statement will execute. Next question, illustrate the purpose of return statement using an example. So we have already seen what is the purpose of a return statement. Here we have written a function to calculate the sum of two numbers. So int add in num1 comma in num2. In sum is equal to num1 plus num2 return sum. The sum is sent back to the calling code. If this is the main function, num1 is equal to 5, num2 is equal to 3. add num1, num2. This is a function call. The function will execute and returns the value to this point, and that value is stored in the variable result. When the add function is called with num1 is equal to 5 and num2 is equal to 3, it performs the calculation sum is equal to 5 plus 3, which results in sum equal to 8. The return statement then sends the value 8 back to the main function where it is stored in the result variable. What are the advantages of using functions in a C program? The advantages of using functions in a C program are code reusability. That is, the function allows you to write a piece of code once and use it multiple times throughout the program. This saves time and effort by avoiding repetitive code. Modularity. Functions break down the program into smaller, manageable parts. Each function performs a specific task, making the program easier to understand and maintain. Debugging and testing. Functions make it easier to isolate and test specific part of the program. If an issue arises, you can focus on a single function for debugging rather than the entire program. Readability. Functions improve the readability of the code by providing meaningful names to the operations performed. Encapsulation. Functions encapsulate specific functionality, keeping the implementation details hidden from other parts of the program. This enhances code security and reduces potential problems. These are some of the questions based on the topic functions in C programming. Thank you.